Have you ever seen a liquid that can be controlled by a magnet? Let's set the stage for a fascinating exploration of a unique substance that blends the worlds of fluid dynamics and magnetism. We're talking about ferrofluids. At first glance, ferrofluids might seem like something from a science fiction universe. These captivating substances are not only liquids but also magnets. They have the uncanny ability to form mesmerizing patterns and shapes in response to magnetic fields. Imagine a liquid that doesn't just flow and splash but can spike, twirl and dance, almost as if it has a life of its own. The science behind this is as intriguing as the spectacle itself. It's a beautiful blend of nanotechnology, magnetism, and chemistry, which gives ferrofluids their unique properties. So, are you intrigued yet? Ready to dive in and learn about the magic of ferrofluids? Buckle up because it's going to be a fascinating journey. So, what exactly are ferrofluids? Imagine a substance that's a liquid, yet magnetic. That's a ferrofluid. In simplest terms, ferrofluids are liquids that become strongly magnetized in the presence of a magnetic field. But of course, there's a bit more to it than that. Ferrofluids are created by suspending nanoscale particles of magnetite, hematite, or some other compound containing iron in a carrier fluid. This fluid could be water, an organic solvent, or even oil. These tiny magnetic particles, we're talking about particles that are about 10 nanometers in size, are coated with a surfactant, a type of compound that prevents them from clumping together. The surfactant keeps the magnetic particles spread out evenly within the liquid so the fluid remains smooth and pourable. This delicate balance allows the particles to float freely in the carrier liquid, rather than sinking to the bottom or sticking together. When a magnetic field is applied, these tiny particles align along the lines of the magnetic field. This alignment creates the spiky, hedgehog-like patterns that ferrofluids are famous for. The stronger the magnetic field, the more pronounced these spikes become. But what's truly fascinating is that once the magnetic field is removed, the ferrofluid goes back to being just a regular fluid. The particles lose their alignment, and the liquid becomes smooth again. It's a bit like a magnetic ballet, with the particles dancing to the tune of the magnetic field. In essence, ferrofluids are a beautiful blend of chemistry, physics, and nanotechnology. They're a testament to the magic that can happen when you manipulate matter on the tiniest scales. And that's the fundamental science of ferrofluids, but how do they behave in real life? Let's find out. Ferrofluids aren't just fascinating in theory, they're absolutely mesmerizing to watch in action. Imagine a drop of dark, glossy liquid, seemingly ordinary and unassuming. But the moment it senses the presence of a magnet, everything changes. It's as if the liquid has been awakened, responding to an invisible call. It reacts instantaneously, springing to life. In the blink of an eye, the smooth surface of the liquid morphs into a series of sharp, jagged spikes. It's like watching a miniature mountain range erupting from a still lake. The spikes align themselves along the magnetic field lines, creating a three-dimensional pattern that showcases the hidden architecture of the magnet's force. The entire spectacle is a dance between liquid and magnet, a dynamic ballet dictated by the laws of physics. The fluid's movement is captivating, almost hypnotic. It ebbs and flows, sways and swells in a constant state of flux. It's like watching a living entity, a creature from another world, performing an intricate dance. The fluid seems to defy the very laws of nature, transforming from a smooth, flowing liquid into a spiky, solid-like structure, and then back again, all in response to a simple magnet. This pulsating, ever-changing display is not just visually stunning, but it also offers a tangible visual representation of magnetic fields. The spikes and peaks in the fluid mirror the invisible lines of force that surround a magnet. It's a visualization of an unseen force, a physical expression of an abstract concept. But the ferrofluid's dance is not restricted to a single form. Depending on the strength and orientation of the magnetic field, the fluid can take on a myriad of different forms. From beautiful, symmetric patterns to chaotic, abstract shapes, the ferrofluid's dance is always unique, always mesmerizing. Isn't it incredible how a simple liquid can transform in the presence of a magnet? But the magic of ferrofluids doesn't stop there. You might be wondering, where do we use these amazing ferrofluids? Well, let's dive in and explore some of their applications, shall we? Ferrofluids have a wide array of uses that span across various fields, from technology and engineering to art and medicine. For starters, in the realm of technology, ferrofluids play a significant role in cooling electronic components. You see, electronic devices generate heat, and if not properly managed, this heat can damage sensitive parts or even cause the device to fail. Here's where ferrofluids come in. They have excellent heat transfer properties, making them ideal for dissipating heat from electronic components. By applying a magnetic field, the ferrofluid can be directed to the areas that need cooling the most, efficiently managing the heat distribution. But the applications of ferrofluids go beyond just cooling. In the world of engineering, ferrofluids serve a crucial function in creating vacuum seals in hard drives and other electronic devices. The magnetic properties of ferrofluids allow them to create a liquid seal that prevents dust and other contaminants from entering the device, thereby ensuring smooth and efficient operation. Moving on to a more creative application, ferrofluids are also used in the world of art to create stunning visual effects. Artists utilize the unique characteristics of ferrofluids to create mesmerizing dynamic sculptures and installations. When a magnetic field is applied, the ferrofluid morphs into intricate patterns that can be manipulated to create captivating displays of art. So in a sense, ferrofluids are not just about science, they're about the fusion of science and art, a testament to the beauty that can emerge when these two worlds collide. And lastly, let's talk about medicine. Yes, you heard that right, medicine. Scientists are exploring the use of ferrofluids in targeted drug treatments. The idea is to use ferrofluids to deliver drugs directly to the site of a disease, such as a tumor. By applying a magnetic field, the ferrofluid which carries the drug can be directed to the exact location where the treatment is needed. This targeted approach could potentially reduce side effects and increase the effectiveness of treatments. While this application is still in its early stages, it's a promising direction that showcases the potential of ferrofluids in transforming healthcare. As you can see, ferrofluids have a wide range of uses, and they're just as practical as they are fascinating. Whether it's cooling your laptop, sealing your hard drive, creating a piece of art, or potentially revolutionizing drug delivery, the applications of ferrofluids are as diverse as they are intriguing. The magic of ferrofluids truly lies in their versatility, and we're only scratching the surface of their potential. Who knows what other applications we'll discover in the future? The possibilities are as limitless as our imagination. So, we've learned a lot about ferrofluids today. We off by peeling back the layers of intrigue that surround these captivating liquid magnets. That's right, magnets that flow like water, yet dance to the tune of magnetic fields. It's as if science fiction has spilled over into reality. We then ventured into science behind ferrofluids. These aren't your everyday liquids, but a cocktail of nanoscale magnetic particles suspended in a carrier fluid. And it's this nanoscale magic that bestows upon ferrofluids their unique behavior. They react to magnetic fields, forming those hypnotic spikes and patterns that seem to defy gravity. Next, we witnessed ferrofluids in action. We watched as they danced and twisted, moved and morphed, all in response to the invisible pull of a magnet. It was like watching a ballet of physics and chemistry, a performance that can't help but leave you spellbound. We also explored the myriad applications of ferrofluids. They found their place in technology, serving as liquid seals in hard drives and damping systems in speakers. They've become the muse of artists, adding a whole new dimension to visual art. Even the field of medicine hasn't been left untouched, with ferrofluids being explored for targeted drug delivery and magnetic hyperthermia. But it's not just about what ferrofluids can do, it's also about what they represent. They stand at the crossroads of science, technology, and art, a testament to the power of human curiosity and creativity. They remind us that even in a world where we think we've seen it all, there are still wonders waiting to be discovered, still magic waiting to be unveiled. And that's the magic of ferrofluids, a liquid that dances with magnets, a marvel of science, and a testament to human. Until next time, keep exploring and let the wonders of science amaze you. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. Stay tuned for more amazing science videos.